Yes, good afternoon, students. Shall we continue for electric charges and field? So there are distribution of charges. There are three types of distribution of charges. One is a linear distribution, another one is a aerial distribution or surface distribution. Charge distributed on its volume, charge distributed on its length, on its area of cross section, and on its total volume. So based on that, there are three types of charge densities: linear charge density, surface charge density, and volume charge density. So what is meant by linear charge density? The charge per unit length is called linear charge density. Charge per unit area, so charge per unit length is called linear charge density. So lambda denoted by letter lambda. So sigma is equal to surface charge density. Charge per unit area is called surface charge density. Volume charge density, so rho is equal to rho. Charge per unit volume is called volume charge density. Volume charge density. So these are the three types of distribution of charges, right? So let us go for. So what is Gauss law? Gauss law. So to find out flux through the Gaussian surface, flux of any charge we are using. So which one? So Gauss law. Gauss law is what? The flux. If it is there is a charge, if it is a charge, so this is charge enclosed by one Gaussian surface. The total flux emanating from this Gaussian surface. So the total flux is emerging from this Gaussian surface, means number of field lines, how many number of field lines it is emanating. The flux through the Gaussian surface is equal to, so 1 by epsilon naught times of the total charge, net charge or enclosed charge. So Gaussian surface के अंदर कितना charge enclose करे वो total charge upon epsilon naught. जो charge बाहर है तो it is not applicable. Gaussian surface का अंदर ही रहना. So we can also write flux a definition integral E bar dot ds bar or dA bar is equal to q net or q enclosed upon epsilon naught. Q enclosed upon epsilon naught. So this is called Gauss law, or simply flux pi is equal to Q by epsilon naught. Q by epsilon naught is called Gauss law. Gauss law. Right? So let us go for continuation, please. So what is the applications? Gauss law, the main purpose of Newton's Coulomb's law we are using to solve it. Electric field due to point charges. But Gauss law we can find out electric field due to, so which one? Distributed charges. For distributed charges we can find out, so electric field by using Gauss theorem. So electric field due to long infinitely charged wire formula क्या है? So electric field due to long wire carrying charge. What is the electric field due to long wire carrying charge? So electric field E is equal to lambda upon 2 pi epsilon naught into R. So lambda upon 2 pi epsilon naught into R. When a charge distributed along its length of the wire, the electric field at any point at a distance r from the conductor at a distance r, so lambda upon 2 pi epsilon naught r, so E inversely proportional to r. So if it is due to plane sheet, so this is conducting on both sides, so non-conducting, a different conducting on both sides it is there. So electric field, so due to plane sheet carrying charge, sigma upon 2 epsilon naught. If it is a thick plane sheet, means only sigma upon epsilon naught. It is a thin plane sheet. If it is a thin plane sheet, that is the sigma by 2 epsilon naught. If it is a thick plane sheet, sigma by epsilon naught. So it does not depends on distance. Let us go for one more application. Electric field due to a spherical shell. So there is one spherical shell which is carrying charge. Charge always resides on the surface of the conductor from the property of the conductor. So we have to find out electric field. See here, So this is charge resides on the surface of the conductor. इसका radius let us assume that r at a point outside. So at a distance r, what is the electric field? On the surface, what is the electric field? So P2 point, P1 point. Inside, what is the electric field? Inside electric field is 0 because of no charge were present. Inside electric field is 0. On the surface electric field is maximum. So E equal to KQ by capital R square. Capital R square. Outside KQ by small r square. So long distance it is looking like a point charge. Point charge. So on the surface outside electric field at this point, outside at point P1, outside KQ by r square outside. On the surface electric field is on the surface KQ by capital R square, and inside at a point P3 electric field inside is 0. Inside is 0. This is the electric field due to conducting spherical shell or conducting solid sphere, all are same. Electric field due to hollow spherical shell, hollow shell, hollow spherical shell, whether conducting or non-conducting, whether conducting or non-conducting, conducting or non-conducting hollow spherical shell, and conducting solid sphere, all are same. Conducting solid sphere, conducting solid sphere, so all are same. Conducting or non-conducting hollow sphere, otherwise or conducting solid sphere का formula भी same है. So this is the electric field due to so hollow spherical shell, whether conducting or non-conducting, otherwise solid conducting spherical shell. Alright, next one please. Shall we go for so this one? So entering flux is equal to leaving flux, that is why net flux is equal to 0. So कितना flux enter कर रहा उतना flux leave कर रहा. So entering flux should be taken as a negative, leaving flux should be taken as a positive. Net flux is equal to 0. और एक बार, so this one, these two long infinite plane sheets are carrying charges positive and negative, positive and negative. So between there is a electric field sigma by 2 epsilon naught plus sigma by 2 epsilon naught. See this one. So here what is the application here? See, so this is one plane. See, so this is one plane sheet, this is another plane sheet, another plane sheet. So it is carrying charge positive, it is carrying charge negative. So at this point, due to positive charge away, due to negative charge towards. At this point, due to positive charge away, let us assume 1, assume 2. Due to positive charge E1, negative charge E2. Due to positive charge E1, negative charge E2. So E1 equal to E2 equal to sigma by 2 epsilon naught. So E1 is equal to E2 is equal to how much? Sigma by 2 epsilon naught. So these both are cancelled, these both are cancelled. Whereas between the plates बात करें तो पॉजिटिव चार्ज के वजह से अवे, नेगेटिव चार्ज के वजह से टूवर्ड्स, दोनों ऐड होता 2 sigma by 2 epsilon naught, 2 sigma by 2 epsilon naught, that should be sigma by epsilon naught, sigma by epsilon naught. Alright, let us go for next one. So this is the applications. Shall we go for solving some questions please here? So please check it. So these are the questions are given by your CUET exam 2023-22. Last 2-3 years जो भी questions दिया वो questions में frame करे इधर. It is given by last to 2023. So now this one, electric field lines. It is inwards. Inwards means negative charge. Negative charge means Q less than 0. Q less than 0. A is belongs to 1. A should be 1. So we have only two options. We have only two options. Whether first option or second option. Whether first option or second option. I will enlarge it please. Just a minute. Right. Right. See. So we have only this one. In this case we have only. So q less than 0 means we have only one option. So two options we have here, two options. So what are the two options? So 2 not possible, 3 not possible, maybe 1 or maybe 4. So don't check it B option, fourth C check करो क्योंकि B 3 है, B also 3 है. Don't check whether D or, so D check करेंगे. D 4 2 है. Yes. So D check करे तो it is a positive charge away from the charge, negative charge towards the charge. It is act as an electric dipole. D belongs to 2. D belongs to 2. We have only one option, fourth option. D belongs to 2. So A belongs to 1, and then so B belongs to third. Why? Because this is what? Away. Positive charge means away from the charge. Q should be greater than 0. Q should be greater than 0. Field lines are away from the charge. Field lines are away from the charge because Q should be greater than 0. So this is unequal charges. So away towards, here more charge, here less charge. Number of lines are less. Number of field lines are less. Here more charge, here less charge. Clear? So let us go for next question, please. Next question, please. In a spherical metallic conductor of radius, just a minute, students. Yes, a spherical metallic conductor of radius 6 centimeters. It is also given by 2023 CUET exam. So, spherical conductor of a radius 6 centimeter held in air. So the maximum charge it can be hold if dielectric strength of air is 20 kilovolt per centimeter will be. What is the maximum dielectric strength? The maximum dielectric strength. So do you want to find out the maximum dielectric strength? So nothing but electric field. The maximum electric field it can withstand without breakdown. So electric field formula you know, KQ by R square. So electric field given 20 kilovolt centimeter. So this is given electric field 20 kilovolt centimeters. It is the radius R given. So the maximum voltage is asking. So E is equal to 20 kilo 10 power 3. So per centimeter, if it will go convert into meter, 10 power 2. 10 power minus 2 नीचे रहता, ऊपर गया तो 10 power plus 2. K value, we know that K value 9 into 10 to the power of 9 K value. So we want to find out charge R square, 6 centimeter square, 6 square 36, 1 centimeter is equal to 10 power minus 2 minus 4. Minus 4 whole square minus 4. Now this one what we can write? So from this we can find out Q is equal to what we can get, Q 9 1 times, 9 4 times. So this one 2 into 10 power 6, 2 into 10 power 6 into 10 power minus 4 multiply करो 10 power 9 you will get the down. So 6 cancel, 3 4 2 is 8 into 4 here 4 also is there, 4 2 is 8 into so 3 10 power minus 7, 10 power minus 7 coulombs. We can write 0.8 microcoulombs. So we can write 0.8 microcoulombs. 0.8 microcoulombs. Right? So let us go for next question, please. Next question, please. For a given charged conducting hollow sphere, arrange the electric field at the given points A, B and C in decreasing order. So in decreasing order we have to arrange the electric fields. So electric field just now we discussed, inside 0, outside is less, on the surface will be maximum. At B is more than C, C is more than A, B is more than C, C is more than A. So you have only one option. So that is first option, electric field at B is more than C and C is more than A, because electric field at point A is equal to 0, on the surface maximum, outside decreases with distance, because E inversely proportional to R square. E inversely proportional to R square. Next one, please. 3 charges plus 4q, q and q are placed along the x-axis at points x equal to 0, L by 2 and L respectively. The value of q to make net force on q is 0. Net force on q we have to make it 0. Net force on q, so we have to make it 0. So when net force on q is equal to 0, what is the q value. So let us go for, there is a one charge plus 4q, here we are placing at origin at x equal to L distance में, so we are placing capital Q. Again L distance में we are placing again L by 2, sorry, this is L by 2, so this is totally L distance में, so we are placing again Q, again Q. So Q charge we are placing, then the value of Q to make net force on Q is 0, on Q net force 0. So इसके वजह से force it is away. So let us, I am assuming point A, point B, D to A के वजह से force is away, D to B के वजह से भी force is away, force D to B charge, the net force is 0, net force 0 means FA plus FB is equal to 0, FA plus FB is equal to 0 means FA, A charge कितना है, K 4Q into Q upon distance is L square, FB force D to capital Q, K capital Q small q upon this distance is L by 2 whole square, L square by 4 is equal to 0. If you equate those, what you will get, see here, this one K 4Q into Q upon L square is equal to minus 4K capital Q small q upon L square get cancelled, Q get cancelled, 4K get cancelled. So capital Q is equal to minus Q. Capital Q is equal to minus Q. Option 4 is correct option. Option 4 is correct option. Shall we go for next question, please? A circular lamina of radius r is having surface charge density sigma coulomb per meter square, electric field at axial distance 2r. So electric field due to a circular lamina due to cone. So what is the disc? Circular lamina like disc. So due to this electric field, so at a distance at point, this is the radius is r. So at a distance this one we can find out, at a distance this one, it makes an angle theta, so this is at a distance x, shall we go for, at a distance electric field at axial distance on its axis at a distance at point, this point, what is the electric field due to this formula? Electric field is how much? Electric field E is equal to sigma upon 2 epsilon naught into 1 minus cos theta. Electric field due to cone or circular disc at any point on its axis, sigma by 2 epsilon naught into 1 minus cos theta. Just a minute, students. Yes. Sigma by 2 epsilon naught into 1 minus cos theta. So sigma by 2 epsilon naught, sigma upon 2 epsilon naught, 1 minus cos theta, adjacent side by hypotenuse, cos theta x upon under root of r square plus x square. Under root of, this is under root of r square plus x square. Now x is equal to 2r is mentioned at a distance, sigma upon 2 epsilon naught 1 minus x is equal to 2r upon under root of r square plus x square, 4r square, x square 4r square. So let us take out common, so r get cancelled, so root 5, 1 minus 2 by root 5, sigma by 2 epsilon naught 1 minus 2 upon root 5. Next one, please. 2 point charges plus 5 microcoulomb and minus 5 microcoulomb are placed at point O. So at point O, this is a point O here. So plus 5 microcoulomb we are placed, plus 5 microcoulomb, and here we are placed minus 5 microcoulomb, then what is the force on plus 5 microcoulomb? इसके ऊपर फोर्स ये डिस्टेंस है ऑलरेडी बोले मैं सॉल्व करके बोल के लास्ट वीडियो में दिस इज 3i दिस इज 4j देन ये डिस्टेंस 3i प्लस 4j दैट इज 5 नाउ इसके वजह से एट दिस पॉइंट फोर्स इट इज अट्रैक्टिंग टुवर्ड्स व्हाट इज द फोर्स दिस वन फोर्स इक्वल टू 9 into 10 to the power of 9 9 into 10 to the power of 9 q1 q2 5 into 5 25 into 10 power minus 12 because of 2 micro 10 power minus 12 k q1 q2 into r bar. What is r bar? 3 I cap plus 4 j cap r bar. So when we take r bar we have to go for r cube at the bottom. If it is r cap means r square, vector notation I am talking. So this is his mentioned vector notation. R cube, r is 5, r is 5. So 5 it is what? Millimeter. 5 cube means, so 5 cube. So 5 5 is a 25, 25 5 is a 125. Otherwise we can go for directly 5 cube 125 multiplied by 1 millimeter equal to 10 power minus 3 whole cube 10 power minus 9 10 power minus 9. So 25 1 times, 25 5 times, 5 1 times, 5 1.8 times, 10 power 9 10 power 9 cancel, minus 3 is present, minus 3 can 10 power 6 is present, 10 power 6, this 10 power minus 3 whole square, right? 10 power minus 3 5 micron 10 power minus 12, okay, 10 power minus 3 5 cube 10 power minus 3 whole cube. So 1.8 into 3i cap plus 4j cap. 1.8 into 3i cap plus 4j cap, you will get option 3. You will get option 3. Please check it. Option 3. It is also milli na, this meter. So then it is also 10 power minus 3 minus 3 minus 6 plus 9 plus 3 10 power 3, yes, 10 power 3, option C. You will get option C. Next one please. Electric field at a surface of the conducting shell of radius r is measured x. Electric field at a distance 3r from the center of the shell. 3r, E inversely proportional to r square. So you know, so 3 times means x by 9. Electric field E2 by, so E1 is equal to r1 by r2 whole square. So E2 we have to find out. E1 is mentioned x. Electric field is x at a distance r. At a distance r, r2 3r whole square, r get cancelled, E2 is equal to x by 9. E2 is equal to what? X upon 9. E2 is equal to x upon 9. Let us go for next one please. So this question already we done in the previous class. Please check it please. Clear? So this is the first chapter. These are the questions what we are I mentioned here, previous year CUET questions. Please go through once, remaining some other questions. So we have to start next chapter in the next session. Please